More than 1 billion people around the world use Chrome every day, and our number one priority is to make sure they stay safe. But just like any software, even that built to the highest engineering standards, Chrome has bugs. Most of those bugs are harmless, but a small fraction of them are exploitable. That means malicious websites might be able to use them to steal your information or even pretend to be you online. We fix any such security bug with great urgency, but there are rare cases where we discover that a bug actually is in use by attackers in the wild, so-called zero-day bugs. In these cases where we discover that a security bug actually is impacting users of Chrome, we have to pull out all the stops to make a fix even more quickly than normal. First, how do we find out about these bugs that are in use? One way is via Google's Threat Analysis Group. That's a team which tracks parties involved in disinformation campaigns, government-backed hacking, and financially motivated abuse. Sometimes they discover that bad actors are using bugs in Chrome or in other software. When they do find a bug that's specific to Chrome, they'll report it to us. For us, this is an emergency scenario. We have evidence that real people using Chrome are being harmed by a flaw in Chrome, and it's up to us to act as quickly as we can to solve the problem and thwart the adversaries. One such emergency was a bug in Chrome's Portals feature. Here's how we handled it. Normally, Chrome keeps each web page locked away in a box, called the renderer sandbox. So, if a website finds a way to make Chrome misbehave, it's still isolated and can't hurt you. In this case, a bug allowed the code to break out, potentially allowing attackers to steal information. Portals is a new feature which will enable one website to animate transitions to another website. Because it involves several websites working together, not all of the code could be locked away safely into one single sandbox. A malicious web page abusing the Portals feature might have been able to use this bug to run its code outside of our sandbox, getting access to information that it shouldn't have been able to reach. A team member in Switzerland flagged this bug and reported it to Chrome through our bug tracker. New Chrome security bugs first end up in a queue for attention by a team we call our security sheriffs, and I'm one of them. My first task is to reproduce the bug, that is, ensure we can actually make the bug occur. We do this so that we can understand how serious it is and gather information on exactly what goes wrong so that we can brief the relevant engineers. As security sheriffs, we'll aim to give the engineers all of the information they need to go ahead and fix the bug as quickly as possible. For zero-day bugs like this one, I also pull in our technical program manager, Amy, who starts to notify teams across Chrome that an urgent release may be required and helps work out how we can most efficiently deliver this fix to all of our Chrome users. For this particular bug, I worked out that Kevin was in charge of this bit of the code and asked if he could take care of getting the fix together.
I came in to find the root cause and discuss with other engineers things we needed to consider before making a fix. For example, would we cause a crash on Chrome or impact other functionality? Once we worked through those considerations, I created and tested a patch to address the root cause. That draft code was reviewed by another person familiar with the affected code and our security sheriff, who tested it within minutes. After going through an initial round of automated testing, the fix landed in the most up-to-date version of the Chrome codebase.
From there, I work with the release team on getting the fix into releases for all of the affected platforms and shipping those releases to people as soon as possible. This sometimes results in shifting schedules to move up a planned release earlier or delaying plans slightly to allow the fix to be included. We needed to make sure the fix wouldn't break any of the ways you use Chrome. When we were certain it wouldn't, we made the decision to roll it out to the impacted channels. In the case of the bug in the Portals feature, we created a new Canary release to test the fix out in the real world. Within a day of Kevin fixing the bug, details were shared with the security teams of all the other organizations making Chromium-based browsers, so they could start absorbing the fix into their products. Then it was my job to decide whether to merge the fix to the beta and stable branches of Chrome. After another test on these versions, the fix was landed in those branches. The stable release candidate went to QA to ensure it was ready for release, and a few hours later, it was rolled out to users.
For the Portals bug, it took about 3 days to come up with a fix and roll it out. On average, our response to a zero-day bug lasts 4 to 5 days. That's from when we first hear about the bug to when we ship that fix to the first wave of users. As you've seen, it takes a lot of people around the world to fix zero-day bugs in a timely manner, and it's all part of Chrome's priority to help keep you safe on the web.